Of Kepler's third law. So Kepler's third law, remember, period squared is proportional to the radius cubed. Okay, so the time for one revolution is related to the time for, or the radius of the orbit, in that rather unusual way. Okay, so remember what we do. Okay, we start off, we have our two objects. We have our central object, and we're going to call that uppercase M, okay, a large mass. And we've the orbiting satellite, and we're going to call that small m. Okay, so that's orbiting in circular motion. Okay, right, now there is a force of gravity between them. Okay, and that's the force that provides the centripetal force towards the center that allows the satellite to go in circular motion. So the force of gravity is supplying the centripetal force. Okay, so we equate them. So the force of gravity comes from, as we know, Newton's law of gravitation. Okay, so it's uppercase G, large M, small m over, in this case, R squared, because we're calling the radius of orbit uppercase R. Okay. The centripetal force is on the satellite, so it's small m or lowercase m v squared, the velocity of the satellite, over the same radius of orbit. Okay. We can now cancel the m's and cancel one of the r's. So we've r here, we've r by r here, so it cancels down to an r there. Okay, and I'll just rearrange, I'll just put the v squared on the left, and we're left with this expression. Now, it's a very important expression, not in tables. Know it. It is used, it's asked sometimes, but we're using it here to get to the final answer. We're not there yet. Okay, right. Our next step then is to bring in periodic time. We want periodic time, so we want to formulate periodic time, and we know from previously that the periodic time is the length of the orbit divided by the velocity. Okay, now remember, just, this isn't part of the proof, but just to come across to that. Okay, right, if you take one revolution, velocity is distance over time, the time is one revolution, the distance travelled is 2 pi r, isn't it? And the time is the periodic time, and we rearrange that. So this formula in itself isn't in the tables, but you can get it very quickly, or again, you'll know it. Okay. Now remember, that's not part of the proof. Okay, because all you do here is put this down. Now you want t squared, so once you have this down, you square both sides. You're nearly there now. And you look at it now, and all that's not here, that is here, is v squared, and you have v squared as gm over r. So you can write it as t squared equals 4 pi squared r squared divided by gm over r, if you like, or rearranging that, 4 pi squared, remember, dividing by a fraction, you invert and multiply, so it's 4 pi squared r cubed over gm. Okay, I can put that here just for those of us who are a little confused what I did there. Okay, if I divide by a fraction, you invert and multiply, as you used to do way back in primary school. And there you go. QED sorted.